All right, friends, hopefully we're recording. Okay, I think I might be. This is tricky business, so don't judge me if it's not super smooth. I'm sure it's going to be amazing. Okay, you should have your page 1, 6.1 notes in front of you. We're going to be talking about the law of sines. So before we talk about the law of sines or the law of cosines, I want to point out a couple of things to you now. Let's see. Okay, first thing I want to point out is everything we have done up until this point this semester has been all about right triangles. But the question is everything a right triangle? And the answer is no, not everything is a right triangle. So what happens when it's not a right triangle? Can we still get information? Can we still use right triangles, which would involve sine, cosine, and tangent, all those good things? Can we still use those things to solve triangles and find out information? So when it's not a right triangle, it's called an oblique triangle. That's over here, right here, oblique triangles. So in order to solve an oblique triangle, you have to know more info. So I want to take a minute and just remind you, we've talked about this before, but I want to remind you that when you name random triangles that are not right triangles, although when I draw triangles, they all end up looking like kind of like right triangles, but that's not. If this is angle A, and remember we use capital letters for angles, and then the side opposite is a lowercase a or a lowercase c or a lowercase b, and that indicates sides. So angles are going to be uppercase, and sides are going to be lowercase. And the important thing is that you know that they're opposite the side with the angle with the same letter. So B is across from B, A is across from A, and C is across from C. Okay, cool. The other thing that we want to remember from back in the day, is do you remember being in geometry and trying to prove two triangles are congruent? So proving triangles congruent. We had ways to do that. We had ways to do it. You could use side, side, side. You could use side, angle, side. You could use angle, side, angle. You could use, what's the other one? What am I missing? Angle, angle, side. These were all ways to prove congruence. And the reason that they were ways to prove congruence is because they give you, what's the word I'm looking for? They give you unique triangles. So if I give you 3 specific side lengths, I say make one side this, make one side that, and make one side this other, and you go to make a triangle, we're all going to get the same triangle. Everybody in class would get exactly the same triangle because there's only one triangle to be made given those specific side lengths. If I gave you a side, like make the side 10 inches, make the included angle 30 degrees, make the other side 15 inches, there is only one triangle that can be made. It is a unique triangle if it follows that same side, angle, and side. Same thing with angle, side, angle. If I give you an angle, an included side, and the other angle, it's going to make a unique triangle. Blah, blah, blah. So you learned all of that back in geometry. And that's why we could use these things in our proofs. There were 2 other possibilities that did not work, if you recall. Angle, angle, angle. So that does not give you a guaranteed unique triangle. It would give you a similar triangle, but that's not enough to prove congruence. And then there was this bad word. Do you remember that? Your teacher probably said there's no bad words in geometry or something along those lines. I like to refer to it as the Haas case. This case is special. It is not enough information to prove congruence. Not good for congruence. However, we can use it. It's not totally lame when it comes to solving triangles. We can use it to find information about triangles. So back to what does it mean to solve a triangle? Solve a triangle. It means have all 6 parts. So solving a triangle means all 6 parts. Find all the angles and all the sides. Depending on which pieces you're given, you should be able to do that depending on the pieces that you're given. If you're given any of these 4 situations, you'll be good. If you're given that situation, you'll be partially good. If you're given that situation, boo, can't do it. So you need to be given 3 out of 6 parts of a triangle. As long as they follow any of these 5 situations right here, you can do something with it. And you want to find the other 3 missing parts. So that's what we're going to talk about right now. I'm going to move this up. Hopefully that was enough. Okay, so solving oblique triangles. So these are triangles that are not right triangles. If they were right triangles, we would use Pythagorean theorem, we would use sine SOHCAHTOA, we would do all of those things, but we don't have that info. So in order to solve an oblique triangle, you must know the measure of at least one side and any two other parts. Now I'm going to scooch this back down. You have to know at least one side. Look, all of these have at least one S in them. You have to know at least one side and any two other parts. If you don't have any sides, it doesn't work. But as long as you have a side and any other two parts, you should be able to figure something out. Okay? So what we're going to talk about with law of sines is if you've got the angle side or the angle side angle case. That's what we're going to talk about today right now. And then the other situation, if you've got two sides in an angle or the has case, you use the law of sines. So today, if I'm going back down to this, today we're going to work on this one and this one. This guy right here is called the ambiguous case. And that's a separate video that I've already done, part 1 and part 2. So this guy is so crazy, he actually has 2 different videos in 2 different parts. And then when we get to law of cosines, that will be this one and this one. So law of cosines is these 2. So today, really right now, all we're looking at are these 2 situations. Now you're gonna wanna have a calculator with you. So if you don't have one, hit pause and go get a calculator. And let's bust a move through this. Now I've just gotta get myself situated here. Sorry, hold on. It's gonna be bumpy. Hold on. Oh, wait, whoa, ooh, oh. Okay, did I do it? Yes, I did. So this is the law of sines. Oh, look at, there it is. That's the law of sines right there. It's very exciting. Let's see, what's important here? So it says, well, I don't know. Look at it. It's pretty cool in all its glory. Now, wait, why did they give it to us 2 different ways? Well, we want to use this one. Let's think. We want to use that one if we are solving, can you see that? If we are solving for a side. And we want to use this one if we are solving for an angle. Okay, so that kind of gives you an idea of when you want to use which. They say the same thing. You are not going to use all 3 at the same time. You are going to use any 2. So like, for instance, you might have information about A's and B's. Well, then you would use that. Or you might have information about A's and C's. So you would use that, right? So it kind of just depends on what pieces. You use 2 out of the 3, but not all 3 of them at the same time. All right, let me move this and see if we can't get you working on a problem like that. Okay, so use the given information to solve the triangle. And remember, solving a triangle means that we're trying to find all the missing pieces. Okay, so start by drawing it. I think that's always the best place to start. I'm a visual girl. I usually make the longest side C, and that means the largest angle is usually going to be C for me as well. And then it really doesn't matter what you make B. Let's call that 45 degrees. That one's B, so that means this is side B. That means this is angle A, and this is side A. So do you notice I've got 3 pieces of information, including a side, which I need. And this is always hard for cuties. Do I have angle, side, angle, or angle, angle, side? Which one do I have to start with? That's the question. So let's see. You always read it in order. Do you see how I've got a side, an angle, and then an angle? Or if I start up here, I've got angle, angle, side. So either side, angle, angle, or angle, angle, side. So I've got this one, okay? This is the one I'm dealing with. If it was this one, A would be the number I'd had. I've had angle, side, angle, but I don't have that, so it's not this one. Okay, so I'm using that, and I need to find this angle, A, side A, and side B. So angle A is going to be angle, well, where do I want to do that? Let's see. I'm not going to do this every time, but I'll do it right now. So angle A plus angle B plus angle C equals 180 degrees. So really angle A is going to equal 180 degrees minus C minus B. And that's going to equal what? The measure of angle, I should be putting a little M right there. Measure of angle A is going to equal I should probably be doing that in my head. Let's pretend that I'm doing it in my head. 15 degrees. Okay, so we just figured out that that is 15 degrees. Cool. Now I've got to find angle A. So I'm going to go back over, ooh, can I see this over here for a second? So I want to find a side. So that means I'm going to be using this one up here. And I've got information about C and I want to find A. So I'm going to use these two right now. I'm going to use those two. Okay, so that's what I'm going to go over here and put. So I've got A over sine A equals C over sine C. Now before I even put in any letters or any numbers in, I'm going to solve for the variable that I want, which is A. So I'm going to multiply this sine A up to the other side. So it's going to be, ooh, Stephanie, dang it. Just pretend that didn't happen. Look at that, it's magic. C over sine C times sine A. Okay. So A is equal to, now I'm going to plug in numbers, 15 over the sine of 120 times the sine of, ooh, that's a, oh, Stephanie, what am I doing? Oh, I do know that one, 15 degrees. And then A is going to be approximately whatever your calculator shoots out. Remember, we don't calculate until the end. I'm going to double check because I feel like I just lost my mind. Let me just make sure I'm right. So I've got that piece, and then I've got that angle, and I'm trying to find across from it. Okay. What am I doing? 15 times. Make sure your calculator is in degrees. Mine is not, so I'm going to fix that sitch. And now I've got, I'm feeling nervous because I have time constraints, and so I'm trying to do this and do it well, but hurry. I have to go pick up my kiddos. Okay, so I just got 4.48. Let's go out to the hundredths, I guess. And that's that. I'm gonna double check everything just to make sure I'm not losing my mind because I am hurrying. So that's angle A is 15 degrees. 60, that's right. Okay, I feel good about it. So now I've got to go and find B, and I'm gonna do exactly the same thing all over again. Let me see if I'm still in the camera. I am. So B over the sine of B is equal to C over the sine of C. Again, I'm solving for B, so that's going to be C over sine C times sine B. So B is equal to a bunch of nonsense. So substitute in 15 over the sine of 120 degrees times the sine of 45 degrees, and now it's a calculator problem as well. Make sure you use your approximation. Make sure your calculator's in degrees. I'll say it again. And then I just got 12.25. So I've got the measure of angle A I need to box. I've got side A that I need to box, and I've got side B that I need to box. Now, does it seem reasonable that A and B are the lengths that they are compared to C? I would, oh, can you even see what I'm doing? Okay, I would argue yes, and the reason why, normally I want somebody to answer this in class, but because I'm talking to myself, I guess I'll answer it. I know. Okay, so this is the biggest side, or the biggest angle, so the biggest side should be across from it. This is the smallest side, so the smallest angle, so the smallest side should be across from it. And this is medium, and so it should be somewhere in between, and it is. Although that still feels a little bit big, I have to say. That feels kind of big. B does. Okay. All right, so there it is. Let's try it again. Let's go again. It's going to be just some examples now. Let me get to what. Okay. All right, so let's draw it. If you want to take a minute and try it and then turn it back on, you can. Like, you could stop the recording or whatever and then come back to it. So go ahead and draw your triangle. Oh, they did not make. C is not the biggest one here. That's a little freaky to me. That makes me scared. Okay, and then A is 20. So here's A, here's C, and here's B. And is this angle side angle or angle angle side? What is this an example of? Angle side angle. So this is the one we're dealing with this time. So again, angle A plus angle B plus angle C equals 180 degrees. And I need the measure of angle A is going to equal, oops, it should be like that. The measure of, ooh, that was weird. I didn't do that up there either. Measure of angle A is going to equal 180 degrees minus 54 degrees minus 41 degrees. Measure of angle A is equal to whatever that equals. .85 degrees. So actually angle A is the biggest angle. That means side A, which is 20, should be the biggest. So we'll make sure that our math matches that. So now I'm wanting to find the two sides. So I'm going to go back up to the law of sines and use the one that says solving for a side. And this time I've got information on A's and I'm trying to find B's. So I'm going to go with A over sine A equals B over sine B. And that's going to be, I'm trying to find side, ooh, nope, I know side A. I'm trying to find side B. So it's going to be B by itself, and I'm going to multiply the sine B up to the other side. I'm doing two steps kind of rearranging. I hope I'm not freaking anybody out. I just multiplied that up and then wrote it, flipped it around when I wrote it. I hope that's okay. And am I still on video up there? I am. Okay, so substitute in some nonsense here. Let's see, 20 over the sine of A, which is 85 degrees. And then the sine times the sine of B, which is 54 degrees. And now calculate. So 20 times the sine of 54 divided by the sine of 85. And I get 16.24. And that seems reasonable for B because it's the next largest. Okay, and now I'm going to find C, and this time I'm going to write it a little bit better for you guys. So I'm going to write the C on this side equals A over sine A. So C is going to equal A over sine A times sine C. C is equal to, I don't know, some nonsense, 20 over the sine of 85, which I just used on the last calculation. And then C is the sine of 41. Find C, or am I still where you can read? Oh no, can you still read it? Oh no, no, no. Okay. 20 times, ooh, Miss Hess just shit divided. 20 times the sine, oh, for the love of Pete. Sine. I'm hurrying people, and that's never a good sign. Sine. So funny. Good Lord, did I do that right? 13.17. So I'm going to box up my angle and both of the sides I just found. Those sides feel okay. They feel pretty good to me based on the angle measures, small, medium, and large, and all that good stuff. Okay, friends. I don't care about that. I don't care about that. Bop, bop, bop. Okay, I think this might be our last example. Okay. Okay, here we go. You should do this one. You should try it without me. Do it and then turn this back on. Pause it and then see if you can do it and then turn it back on. We're getting out of space here, so I'm going to get all crafty and draw a line. And now I'm going to draw a triangle. Again, I know some of you think you don't need to draw triangles. I would always draw the triangle. This is 102.3. Don't underestimate the power of a visual aid. This is B, which is 28.7 degrees, 27.4. This is my A value. That's little a. This is little c. Okay, so more of the same. Which one is this one? Angle, side, angle. Take a second and see if you can figure it out. Angle, angle, side. Which one? Oh, did I just give you angle, angle? Oh, no, I did give you angle, angle, side. Yep. Angle, angle, side. Okay. So let's see here. Find the missing angle. The measure of angle A is going to equal 180 degrees minus 102.3 degrees minus 28.7 degrees. Duh bears. That's an old joke you wouldn't get because you're babies. It was an old Saturday Night Live skit, but you don't care. Do you even know what Saturday Night Live is? Tub ears. Okay, 49 degrees. Okay, so now, let's see. So that is this little cutie right there. And now I'm going to find side A using A over sine A. And then what's the one that I have both pieces of information? It looks like it's B right here. Can you even see everything? Yeah, okay. It's B right there. So I'm going to go with little b over the sine of angle B. And then I'm going to find side A by multiplying that up. Okay. Okay. Sine of 28.7 degrees times sine of, oh crap, am I right? No, I am right. Sine A is 49. Don't you feel confident when your teacher goes, oh crap, am I right? It's really good stuff. 27.4 times sine of 49. What's that? Divided by the sine of 28.7. Okay, 40, I got 43. Ugh, that feels scary. Oh no, okay, 43.06. I always want to box your answers. There's a lot to see on these, and it's going to get worse when we look at the ambiguous case, and so make sure you're always boxing your answers so I can find it easily. Okay, and then finally I need to, so I've got everything up here except for side C. Ooh, I don't have a good example in here where you're finding the angle instead of, I think there's some in your homework like that. Shoddy work by your teacher. I should have made sure you had one of those. What am I doing right now? Who are you? I'm using B, sorry. Just lost my mind temporarily. It's all good. Times the sine of C. C is equal to 27.4 over the sine of 28.7 times the sine of 102.3 degrees. That's degrees as well. Okay. Oh, it's hot in here and my air just kicked on and that is glorious. Sine of 102.3 divided by the sine of 28.7. I got 55.75. 55.75. Okay. Let's double check and make sure our answer seems reasonable. That is the biggest side, and it should be because it's the largest angle. Okay, that looks pretty good. Okay, so we're almost done. The only thing I would say is that I'm a little bit bummed that all of these, what I'm talking about, all of these used, sorry, my little tripod here gets in the way. All of these used this. Sometimes you need to find the angle, and I should have had an example in here where you have to do that. So like if it was asking you to find side C, or angle C. Well, no, actually, did I just lie to you? All of these have, no, I lied. I'm totally sorry. You don't need this until we get to law of cosines. When we get to law of cosines, sometimes you're going to want to use this. But right now, we're doing angle, side, angle, and angle, angle, side. And so we don't need it until we either get to the ambiguous case or to law of sines. So this one right here shouldn't be on your homework. It should be waiting until we get to these problems. Now, I do want to take a second before I sign off on this thing here, on this here thing, and go to your next page of notes. Sorry, I can't really see what I'm dealing with. Are you looking at this? Okay. I'm not dealing with this. We don't have time. It's not hard and it's not that big of a deal, but we just don't have time. So when you get to any problems, sorry, let me deal with my tripod. If you get to any problems that look like this on your homework, just skip them. We'll talk about it. And this right here is your homework. I'm pretty sure there's one, maybe even two of these in there. Don't stress out about them. We can talk about them when I do see you on either Tuesday or Wednesday. Okay, and then now for your next video, when you're ready, that's going to be this one about the ambiguous case, the Haas case, as I like to call it. We'll just go like that. The Haas case, you've got part one where it goes over how you actually build them and why there are so many choices. And then part two actually does the algebra with you. So you're going to, You'll figure it out. You'll see. I gave you the worksheet for it. Good luck. I think you should rewatch this video like 12 times because it's fascinating. Yeah, good luck. I'll see you next week. Okay, bye.